SmartShipping aims to build the most complete weather routing system for maritime transport. The motivation for this project has three main reasons. First of all, economical. We estimate that our system can save from 2 to 7% of the fuel consumption in maritime transport, depending on the route and the ocean conditions. Fuel costs are up to 60% of the total operation costs of maritime transport. The price of bunker fuel has doubled in the last year. A large container ship consumes around 150 metric tons of fuel per day. In 1 year, a single ship can save around $1 million by a wise choice of routes. The second important aspect is environmental. The International Maritime Organization is imposing severe restrictions to reduce the greenhouse gas emissions from the fleet. Even though sea transport is still by far the most efficient way to move freight, it is still responsible for almost 3% of the global carbon dioxide emissions. The compromise of the IMO is to reduce this quantity by 40% by 2030. All vessels are now required to register the fuel consumption to calculate an efficiency index, and those vessels that do not meet the efficiency criteria will very soon no longer be allowed to operate. We estimate that SmartShipping can reduce carbon dioxide emissions by at least 2%. This is equivalent to removing 4 million cars from circulation. Last but not least, the third important aspect concerns security in seafaring. A recent study shows that 50% of accidents in the sea involving casualties and loss of cargo are always due to sailing under adverse weather conditions. Ocean currents, winds, and waves can have a considerable impact on the consumption of a ship. Weather routing is the field that uses this information to find the best possible route for a ship to operate between two ports. But clearly, the optimal route might be very different, whether we depart today or whether we depart, say, a week from now. Similarly, the optimal route for two ships departing on the same day might be quite different depending on the type of ship, because different ships interact in a different way with the ocean conditions. For this reason, SmartShipping needs three main components. First of all, we need accurate data on ocean currents, winds, and waves, and of course reliable predictions into the future. We also need consumption and emission modeling, which are personalized to each particular vessel and the different ocean conditions. Finally, we need optimization algorithms which operate on the data and the models, and they're able to find the best possible route. Data on ocean currents, wind, and waves are provided by simulation and forecasting models at NOAA and Copernicus. These values are given on a fine grid and they're updated every day, and they include forecasts into 7 or 10 days into the future. Predictions a few days ahead might have a larger uncertainty, and these facts should be considered when optimizing the route. The SmartShipping project aims to build accurate models for the fuel consumption and emissions of every given vessel. Our team of naval engineers use artificial intelligence to improve the simulation of fluid structure interaction for a given hull, and they're able to calculate fuel, emissions, and safety parameters adapted to every specific ship and ocean conditions with a high degree of accuracy. In addition, having access to the historic consumption data of a vessel allows us to further adapt the model to the sailing conditions. This accurate modeling is one of the key features of the SmartShipping project. We use the most advanced optimization techniques to explore all possible solutions and find the routes that better match the desired criteria. We can optimize for shortest time, for smallest consumption, for the safest route, or a combination of all of these criteria to be fixed by the ship owner. We can also configure a system to avoid certain areas, to consider sailing in areas with low emissions, and to find routes that respect marine wildlife and the environment. A distinctive feature of our algorithms is that they will take into account the uncertainty which is inherent in weather and ocean predictions, in order to have a robust optimization. This is a complex mathematical problem, and we have a team of researchers in several universities working to solve this problem. The advantage of SmartShipping and weather routing systems is that they can be adapted to any kind of ship propulsion systems. We are very interested in performing simulations, for instance, to analyze the trade-off for the new innovative family of wind propulsion systems. believe smart shipping will have a big impact in maritime transport, achieving safer, cleaner, and more efficient routes.